Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is find the student that will replace the chalk. Okay, so the problem statement goes like this: there will be n students in a class numbered from 0 to n minus 1. Okay, and the teacher will be giving each student a problem, starting with the student, the first student, which is the 0th indexed one. Okay, and the student, then the student numbered 1, and so on until the teacher reaches the last student, which is the n minus 1th student. Okay, and after that the teacher will restart the process. Okay, and the teacher will keep assigning the problems to the student. Okay, in this way, starting from the 0th student, going till the last student, and then starting again from the 0th student. Okay, and you are given a zero indexed array chalk, and an integer k will also be given to you. So initially, you will be having, or let's say the teacher is having k pieces of chalk, or the classroom is having k pieces of chalk. When the student, at a particular indexed student, let's say the 0th student, want to solve a problem, then the student will use the number of chalks that is corresponding to the entry of on that particular index in this chalk array. Okay, so if it is the ith student, it will use the number of chalks available at the ith index of this chalk array. Okay, and the pieces of chalk, okay, and however, if the current number of chalks is strictly less than the required chalks by that student, then the student will be asked to replace the chalks, or in a way to get more supplies of chalk. Okay, so what you have to do is you have to return the index of that student who will be getting these more chalks, or more supply of chalks once they are exhausted, when that particular student was wanting to solve the problem. Okay, in a way you can say that that particular student will not be having sufficient chalks, so you will be returning the index of that student. Okay, so before thinking of an approach, it's advisable to have a look at the constraints so that you should be able to solve uh, the problem in the given constraints effectively. Otherwise, you might get a TLE, and you will just end up wasting your time thinking about a wrong approach that will eventually not be getting accepted. TLE is basically time limit exceeded. So, according to the constraints, this chalk array will be of length n, and this n will be ranging from 1 to 10 raised to power 5, and each entry in this chalks array, the number of chalks required by a student at a particular index, will be also ranging from 1 to 10 raised to power 5, both inclusive. Okay, and the number of chalks that you will be initially having, or you can say the k, will be ranging from 1 to 10 raised to power 9. Okay, so these are the constraints. Now let's think of an approach to solve this particular one. So the very first thing that came into my mind while solving this, see, after reading the problem statement, was that since we have to tell what will be the index of the student at which the supply of the chalks will be running out. Okay, so what we need to do is, if let's take one example, one of these examples that is given to us. So let's take the very first one. Okay, so let's say this is the input that is given to you. Okay, so what you should be thinking of is, you should be trying to make a scenario where you have, taken some turns over this array. Those turns can be 0 to as much as these chokes are there. Okay, or whatever the requirement was. uh, there will be a situation when the student, the remaining chokes will be such that, let's say we have a variable remaining chokes, that it would not be able to cover the need of the entire array. Okay, so we want to arrive at that situation. So what is the situation? The number of remaining chokes will not be able to cover the entire array. For that, to induce that situation, what we will be doing here is we will be taking a total of the number of chokes available in the array. Okay, number of choke requirements, you can say. Okay, do a total and let's call this total need. Okay, or total chokes need. Okay, whatever you may want to call it, let's call it total needs. Okay, and what comes out to be the total need? 5 plus 5 11, 5 plus 5 10, and plus 1 11. Okay, so the total need comes out to be 11. And what you will be doing in order to induce this situation, you will be taking modulo of k with this total need. Okay, and even if we are not using k, let's initialize remaining chokes with k value. And then what you will be doing here is you will be taking a modulo of remaining chokes will be equal to modulo with respect to total needs. Okay, so since here 11 is perfectly dividing 22. Okay, so the modulo operation will result into the remaining chokes being 0. Okay, so the new value of remaining chokes will be 0. Okay, because of this operation. Okay, or you can remove the equal to. Okay, so because of this operation it resulted into 0. That's why remaining chokes became 0. So you are right now having 0 remaining chokes. Now the situation have been induced and you are at a situation where the number of remaining chokes will not be able to cover the entire array. Now the second step will be to traverse the array index by index. Okay, to traverse the array. I am talking about chokes array here the whole time. To traverse the array index by index. Okay, at the first index you will be having 0 chokes and 5 chokes were required. So you already found the student at which chokes will be running out of the you will be running out of the supply of chokes. Okay, so 0 will be the index. Okay, let's take one more example. So let's take the second one. So as we discussed, we need to do the summation. So 3 plus 4 7 plus 3 10. Okay, so the total need is of 10 chokes. Okay, and remaining chokes will be initially equal to k. Now you will be doing the modulo operation. So remaining chokes modulo k. Okay, so what will be the new value of remaining choke? It will be 5 only, because 25 modulo 10 will be 5. So 5 chokes will be remaining. Okay, now let's quickly mark the indices. Let's use a different color. So 1 2 0 1 2 3. Okay, so 5 chokes are remaining. So the first one was requiring 3 chokes. So out of 5 chokes, 3 are gone. So we are only left with 2 chokes. Then the second one was requiring 4 chokes, but we are having less than the requirement. So this will be the index of the student, which will be replenishing the supply of, or renewing the supply of chalks. Okay, so one will be your answer. Okay, the index of that student. So as you can see, one is our answer. So you need not to think about that much long process. So you just will be inducing the situation where the number of remaining chalks will not be able to cover the entire array. Okay, once you are having that situation, you will be doing a index by index traversal. Okay, and then you will be able to find the student at which the supply of the chokes will be running out. Okay, so let's see how we have implemented this approach. For that, I will be bringing the code to the board, and let's take a fresh slide for that. So this is the code. So what we are doing here is, okay, and let's zoom in a little bit so that it will be more clear to you. Yeah, I think it should be visible enough. Now let's begin. So what we are doing here is, first of all, as I told you, you should be needing, you will be needing, this chokes, total chokes needed variable. For that, you will be just be doing a summation of the choke needs represented by this chokes array. Okay, once you have done that, and keep in mind the constraints were a little bigger here because 10 raised to power 9, 10 raised to power 5, and was the order of entry and the number of students also. So that's why I took a long value here. So in order to avoid any cases of running out of the range of integer data type, it is advisable to use a bigger data type. Okay, so once you have this total chokes needed, then you will be inducing the situation. Okay, inducing the situation where chokes array will not be entirely covered by the total remaining chokes. Okay, so this is what we are doing here. Firstly, we are initializing the remaining chokes with the value of k. Then we are inducing the situation with the help of this modulo operator. And then once you are having the remaining chokes, you will be doing a index by index traversal. This is the second step. Okay, index by index traversal. So you will eventually reach a index at which the student was not able to make up to the number of chokes he will be needing or she will be needing. In that condition, you will be returning the index of that student. Okay, otherwise you will just keep subtracting the number of chokes that are left from by the current need of the student, and you will keep continuing this. And although eventually you will be running out of the supply, I am returning just a -1, although it will never reach. Okay, so this is the solution for the problem statement. And if we want to have a discussion about the complexities, then time complexity wise, it's order of n, where n is the number of students or the size of this chokes array. Okay, because we are just doing couple of linear traversals. This was also linear and this was also linear, so we are just fine here. And space complexity wise, since you are just using couple of variables and some variables for the loop, so you are not using any extra space, so it will be constant for order of 1. Okay, so this is the time complexity and this is the space complexity. If you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.